Good morning students. In the previous session we discussed about laws of indices or laws of exponent. That is, first law of exponent is a to the power of m into a to the power of n is equal to a to the power of m plus n. This is the first law of exponents. Right? Second law of exponent is a to the power of m by a to the power of n is equal to a to the power of m minus n. Right? Third law of exponents is a to the power of m whole to the power of n is equal to a to the power of m into n. Next, fourth law of exponents is ab whole to the power of m is equal to a to the power of m into b to the power of m. So last one, fifth law of exponents is a by b whole to the power of m is equal to a to the power of m by b to the power of m. Okay. So in this class we are going to solve some problems using this formula. Okay. Let us discuss some problems. First one, a to the power of m plus n into a to the power of 2m minus n divided by a to the power of m minus n. Here a to the power of m plus n can be written as a to the power of m into a to the power of n using first law of exponent. You know that first law of exponents is a to the power of m into a to the power of n is equal to a to the power of m plus n. Similarly, a to the power of m plus n can be written as a to the power of m a to the power of m into a to the power of n. So similarly, here a to the power of 2m minus n can be written as a to the power of 2m into a to the power of minus n into a to the power of 2m into a to the power of minus n divided by, here also this can be written as a to the power of m into a to the power of minus n using first law of exponents. Here observe a to the power of minus n, a to the power of minus n get cancels. Here a to the power of m, a to the power of m get cancels. So remaining terms. Here a to the power of n into a to the power of 2m. So this is equal to a to base is same, so add the power according to first law of exponents. So n plus 2m. N plus 2m. Okay, next second problem. Simplify. Three to the power of n plus 1 plus 3 to the power of n, whole thing divided by 3 to the power of n minus 3 to the power of n minus 1. Okay. Here also, by using first law of exponents, 3 to the power of n plus 1 can be written as 3 to the power of n into 3 to the power of plus 1. So write plus 3 to the power of n as it is. Whole thing divided by 3 to the power of n minus, here so 3 to the power of n minus 1 can be written as 3 to the power of n into 3 to the power of minus 1. Okay, 3 to the power of n into 3 to the power of minus 1. Here observe 3 to the power of n this into 3 to the power of 1 is the first term, 3 to the power of n is the second term. In these two terms we observe 3 to the power of n as the common terms. Therefore, take out 3 to the power of n as the common term. Remaining terms are here 3 to the power of 1 plus here 1. Whole thing divided by, in these two terms take out 3 to the power of n, the common term. Remaining terms are here plus 1 minus 3 to the power of n is common. Here remaining term 3 to the power of minus 1. So 3 to the power of n by 3 to the power of n get cancels. Here 3 to the power of 1 means 3. 3 plus 1, 4. 4 by 1 minus, here 3 to the power of minus 1 can be written as 1 by 3. Take into denominator 3 to the power of minus 1. It becomes 1 by 3 to the power of plus 1 or 3. Okay. So now simplify. So subtract these two terms. Find the LCM for the denominators. Your denominator is 1. So LCM for 1 and 3 is 3. Now multiply each term by LCM. So LCM is 3. 1 into 3. 3 minus 1 by 3 into 3. 3 3 get cancels. 1. So 4 by 3 minus 1. 2. 2 by 3. Take this term into numerator. Becomes 3 by 2. So 2 2s. So 2 into 3 6. Okay. Next problem. Next problem, third one. 2 to the power of b into 2 to the power of b minus 1 whole cube divided by 2 to the power of b plus 1 into 4 to the power of b into 16 to the power of b by 2 divided by 8. Okay. Now first here express 16, 4, 8 in terms of 2 because here 2 is the minimum value. So express 4, 8, 16 in terms of 2. Okay, first write 2 to the power of b as it is. Here 2 to the power of b minus 1. This can be done as multiply these two powers. So 3 into b, 3b minus 3 into 1, 3 into here express 16 in terms of 2. So 16 can be done as 2 to the power of 4. 4 to the power of b by 2 whole thing divided by 2 to the power of b plus 1 can be done as 2 to the power of b into 2 to the power of plus 1 using first law of exponents. Here 4 can be done as 2 square. 4 to the power of b. So here 8 can be done as 2 cube. Next simplify. 2 to the power of b, 2 to the power of b get cancels. Here 2 to the power of 3b minus 3 can be done as 2 to the power of 3b into 2 to the power of minus 3 into 2 to the power of 4 into b by 2. 4 into b by 2. 2 to the, so 2 into b, 2b. 4 into b by 2 is 2b. 2 to the power of 2b divided by 2 to the power of 1 is 2 into 2 to the power of 2 into b, 2b into 2 cube. 2 to the power of 2b, 2 to the power of 2b get cancelled. So remaining terms 2 to the power of 3b into 2 to the power of 3b into 2 to the power of minus 3. 2 to the power of 3b into 2 to the power of minus 3. So take this term into numerator. Here 2 to the power is 1. 2 to the power of plus 1 becomes 2 to the power of minus 1 into 2 to the power of minus 1 into here 2 to the power of plus 3 becomes 2 to the power of minus 3. 2 to the power of minus 3. So now apply a first law of exponents. Base is same, so add the powers. 3b minus 3 minus 1 minus 3 is equal to 2 to the power of 3b minus 3 minus 1 minus 4 minus 4 minus 3 minus 7. So 2 to the power of 3b minus 7. Okay. Next problem. Fourth problem, x to the power of a by x to the power of b whole to the power of a plus b into x to the power of b by x to the power of c whole to the power of b plus c into x to the power of c divided by x to the power of a whole to the power of c plus a. Okay, now simplify. Here x to the power of a, write as it is, into, take this term into numerator. So it becomes x to the power of minus b, x to the power of plus b becomes x to the power of minus b whole to the power of a plus b, right, as it is. Here also write x to the power of b as it is into, take this term into numerator, x to the power of plus c becomes x to the power of minus c whole to the power of b plus c into, here x to the power of c into x to the power of plus a, take into numerator, it will become x to the power of minus a into, whole to the power of c plus a. Now here simplify, base is same, so add the powers, apply first law of exponents, x to the power of a minus b whole to the power of a plus b. Here also apply first law of exponents, base is same, so add the powers, b minus c whole to the power of b plus c here. So same, c minus a, x to the power of c minus a whole to the power of c plus a. Okay. Now here apply third law of exponents, a to the power of m whole to the power of n can be written as a to the power of m into n. So multiply these two powers, x to the power of a minus b into a plus b, a minus b into a plus b is a square minus b square into, here also b minus c into b plus c is b square minus c square into, here c minus a into c plus a is c square minus a square. Now apply a first law of exponent, that is base is same, so add the powers, is equal to, add the powers, a square minus b square plus b square minus c square plus c square minus a square. Okay, here plus a square minus a square get cancelled, minus b square plus b square get cancelled, minus c square plus c square get cancelled. Remaining term is 0, x to the power of 0. So x to the power of 0 is equal to 1. Okay, next problem. Next problem, fifth one. B is root of x to the power of b divided by x to the power of c into a is root of x to the power of c divided by x to the power of a into a with root of x to the power of a divided by x to the power of b. Simplify this problem. Okay, now here we know that suppose root 2 can be written as, square root can be written as 1 by 2 to the power of 2. Cube root can be written as 2 to the power of 1 by 3. So fourth root can be written as 1 by 4, 2 to the power of 1 by 4. Similarly, here bcth root can be written as 1 by bc. So write x to the power of bc divided by x to the power of c as it is. So 1 by bc, bcth root becomes 1 by bc. Okay, into here also x to the power of c divided by x to the power of a AC through it. This can be written as 1 by AC into here AB through this can be written as 1 by AB, x to the power of A divided by x to the power of B, O to the power of 1 by A B. Okay, now simplify. So multiply, split power to each term. So x to the power of B, O to the power of 1 by BC divided by x to the power of C, O to the power of 1 by BC. Using fifth law of exponents, A by B, O to the power of M can be written as A to the power of M divided by B to the power of M is split power to each term into this can be written as x to the power of C, O to the power of 1 by AC divided by x to the power of A, O to the power of 1 by AC into here x to the power of A, O to the power of 1 by AB divided by x to the power of B, O to the power of 1 by AB. Okay, next x to the power of, there are two powers, multiply these two powers, B into BC. So B into BC, B get cancelled, remain term 1 by C. X to the power of 1 by C divided by C into B by C. C get cancelled, remain term 1 by B. X to the power of 1 by B into here C into 1 by A. C get cancelled, remain term 1 by A. X to the power of 1 by A divided by here x to the power of A into 1 by AC. A get cancelled, remain term 1 by C. 1 by C into x to the power of A into 1 by A get cancelled, remain term 1 by B. X to the power of 1 by B divided by x to the power of B into A by B. B get cancelled, remain term 1 by A. X to the power of 1 by A. Now here x to the power of 1 by A divided by x to the power of 1 by A get cancelled. So x to the power of 1 by C, x to the power of 1 by C get cancelled. X to the power of 1 by B divided by x to the power of 1 by B get cancelled. So remaining term is 1. Okay. Next problem. Next main, second main, prove the following. First question, prove that 1 by 1 plus x to the power of p minus q plus 1 by 1 plus x to the power of q minus P is equal to 1. Okay. So consider LHS. Consider LHS. LHS is here 1 by 1 plus x to the power of P minus Q plus 1 by 1 plus x to the power of Q minus P. Here we want to prove is equal to 1. So next simplify 1 by here 1 plus x to the power of p minus q can be written as x to the power of p into x to the power of minus q. So take this term into denominator, it becomes x to the power of minus q becomes x to the power of plus q. Okay, here x to the power of minus q becomes x to the power of plus q plus 1 by 1 plus here also x to the power of q minus p can be written as x to the power of q into x to the power of q into x to the power of minus p. Take x to the power of minus p into denominator, it becomes x to the power of plus p. Okay. Now add these two terms. Write 1 as it is in numerator. In denominator, here we have fraction. So find LCM for denominators. Here LCM is 1. Here denominators are 1 and x to the power of q. Therefore LCM is x to the power of q. Next multiply each term by LCM. 1 into x to the power of q, x to the power of q, plus multiply this term by LCM. LCM is x to the power of q, x to the power of q, get x to the power of q into x to the power of q get cancels. The remaining term x to the power of p. Okay. Plus 1 by, here also add these two terms. So LCM is here x to the power of p. So multiply each term by LCM. 1 into x to the power of p, x to the power of p, plus x to the power of q by x to the power of p into x to the power of p, x to the power of p, x to the power of p get cancels. So remaining term is x to the power of q. So next take this term into numerator. It becomes x to the power of 1 into x to the power of q divided by x to the power of q plus x to the power of p. One into x to the power of q plus x to the power of p divided by x to the power of q. Take into numerator becomes into x to the power of q, x to the power of q by x to the power of q plus x to the power of p, plus 1 into, here also take this term into numerator. It will become x to the power of p divided by x to the power of p plus x to the power of q, x to the power of q. Okay, next 1 into x to the power of q, x to the power of q divided by x to the power of q plus x to the power of p, plus 1 into x to the power of p, x to the power of p divided by x to the power of p plus x to the power of q. This can be written as x to the power of q plus x to the power of p. Okay, commutative property. Now add these two terms, fraction, therefore LCM. For the denominator, observe denominator is same, x to the power of q plus x to the power of p. Therefore LCM is x to the power of q plus x to the power of p. So directly add the numerators, x to the power of q because denominators are same, x to the power of q plus x to the power of p. So this term get cancelled, is equal to 1. This is equal to RHS. Therefore 1 by 1 plus x to the power of p minus q plus 1 by 1 plus x to the power of q minus p is equal to 1. Okay. Next problem. Next problem, second one. Prove that x to the power of b minus c all to the power of a into x to the power of c minus a all to the power of b into x to the power of a minus b all to the power of c is equal to 1. Okay. So consider LHS. LHS is equal to x to the power of b minus c all to the power of a into x to the power of c minus a all to the power of b into x to the power of a minus p all to the power of c. Okay. Next. So apply third law of exponent. There are two powers. Multiply the powers. B minus c into a. B minus c into a or multiply b minus c by a into b, ab minus a into c, ac into x to the power of. Here also multiply these two powers. C minus a into b or multiply c minus a by b. b into c, bc minus b into a, ab or ba. Okay. Next, x to the power of c into a minus b or a minus b into c. c into a, ca or ac minus b into c, bc. Okay. Now observe base x, x, x. So base is same. So add the powers. So means apply first law of exponents. Add the powers. Powers are ab minus ac plus bc minus ab plus ca minus bc. Okay. So x to the power AB minus AB. AB minus AB get cancelled. Minus AC plus AC get cancelled. Plus BC minus BC get cancelled. So remaining term is 0. So x to the power of 0 is 1. So this is equal to RHS. Equal to RHS. Next problem, prove that x to the power of a plus b divided by x to the power of b minus c o to the power of a minus c into x to the power of b plus c by x to the power of c minus a o to the power of b minus a into x to the power of c plus a by x to the power of a minus b o to the power of c minus b is equal to 1. Okay. Consider LHS. LHS is equal to here x to the power of a plus b. So divided by x to the power of b minus c o to the power of a minus c into x to the power of b plus c by x to the power of c minus a o to the power of b minus a into x to the power of c plus a by x to the power of a minus b o to the power of c plus b. This is LHS. Here we want to prove this is equal to 1. Now simplify x to the power of a plus b. Take this term into numerator. It becomes x to the power of minus of b minus c. Minus of b minus c. So minus of b minus c means minus b plus c. Minus into minus plus c. So minus b plus c. Minus b plus c. O to the power of a minus c. Here also x to the power of b plus c, right, as it is, into take this term into numerator. X to the power of this c minus a becomes minus of c minus a. Minus into c minus c minus into minus a plus a. O to the power of b minus c into x to the power of, right, x to the power of c plus a as it is, into take this term into numerator. It will become x to the power of a minus b becomes minus of a minus b. So minus into a minus a minus into minus b plus b. O to the power of c minus b. Now a base is same, so add the powers using first law of exponent. X to the power of a plus b minus b plus c. O to the power of a minus c into, here also apply first law of exponents. Base is same, so add the powers. B plus c minus c plus c. O to the power of b minus c. X to the power of c plus a plus, sorry, minus a plus b. O to the power of c minus b. Here plus b minus b get cancelled. Here plus c minus b get cancelled. Here plus a minus a get cancelled. Now simplify. So x to the power of, remaining terms are here, a plus c. A plus c, o to the power of a minus c into x to the power of a, b plus a. B plus a, o to the power b minus a. B minus a. Here x to the power c plus b. C plus b, o to the power c minus b. So multiply these two powers. X to the power of a plus c into a minus c, a square minus c square. Okay, next. X to the power of b plus a into b minus a is b square minus a square into x to the power of c plus b into c minus b is c square minus b square. Now base is same, add the powers. So using first law of exponents, that is x to the power of a square minus c square plus b square minus a square plus c square minus b square plus a square minus a square get cancels, minus c square plus c square get cancels, plus b square minus b square get cancelled. So this is equal to x to the power of, so remaining terms 0. X to the power of 0 is 1. This is equal to RHS. Equal to RHS. Okay. We will continue on next class. Thank you.